Hi, this is Miss Rosenthal. I'm here for Unit 2 in Geometry, Section 2D Notes. But first, a question of the day. What do you call more than one L? A parallel. I know, they only get better. So let's take a look at our last section here. We're basically going to put many things that we've already learned together, and it's called solving right triangles. In right triangles, actually in all triangles, there are 6 pieces of info that you can find. 3 different angles and the measure of 3 sides. When we are solving a right triangle, they'll give us some information, but we need to use some things that will help us find a missing piece. So one of the rules that we can use that we learned first semester is the triangle sum. Okay, if you remember, the triangle sum is the sum of the 3 angles is going to equal 180 degrees. So when can I use that? If I have 2 angles, then I can use it. Okay, and their sum of 3 angles is 180. Now, these are all right triangles, so one of the angles will always be 90. And so if you have the other angle, you can use the triangle sum to help you find the third angle. A second thing that you can use that we learned at the beginning of this is the Pythagorean theorem. Okay, the big question we had on Pythagorean theorem was, if I know 2 sides, okay, if I have 2 sides, then I can use the Pythagorean theorem to help me find the third side. Sorry, this should be have. Okay? And then the 2 latest things that we've learned are using trig to find side and trig to find angle. Okay? So when am I going to use trig? Well, I'm going to use that if I have a side and an angle. Okay, and so if you remember, trig is always, well, we'll just put SOHCAHTOA up here because that's what it's always helpful. And then when we write our equation, we have to remember it's going to be our trig, whatever one we choose, and then the angle, we put theta, and then the ratio, whatever that is. So that same order is true for both this one and this one. So in this one, if I have 2 sides, and just a 90. So fine. In other words, if I'm looking for those acute angles, that's what I would do. So this is the same thing as down here. Just as a remembrance that to find an angle, I'm using the inverse button, such as sine -1, cosine -1, tan -1. Okay? So let's come down here. You can see here I've got triangle ABC. Take a look at what you have. Well, I have, in angles, I have a 90, I have a 39, and a 1 that I don't know yet, and I have one side that's 11. So the 3 things I need to find are angle A, side CB, and side AB. So if you look up here, which one you're going to use, I think the easiest one is to find angle A. These 3 have to total 180. So angle A plus 39 plus 90 has to equal 180. When you work all that out, you should get 51 degrees for angle A. Okay, when you add these together, subtract from 180, you should get 51. Okay, so angle A, I'm going to put over here, 51. I'm going to write up here because I can use it, 51. Now all I have to do is find 2 sides. So I'm going to use this angle that they gave me, and I'm going to say I want to find the hypotenuse. Well, with this angle, I'm also given the 11, which is the opposite side, and I'm trying to find H. So OH, that signifies sine, angle 39 equals opposite over hypotenuse. So there's our setup. If the variable's on the bottom, it's a divide problem. So 11 divided by sine 39 equals. And this is going to be a side, so go around to the nearest tenth, 17.5. So this side right here, 17.5. That is AB, 17.5. Oh, gosh, only one more to go. How can I find CB? I'm just going to make that X. Okay, well, there's two ways I can find that one. I can use trig, or I could use Pythagorean theorem. Because I have two sides now, 11 and 17.5, I can use those to help me find the third side, and that's exactly what Pythagorean theorem is for. So if I was going to set that up, I'd say x squared plus 11 squared equals 17.5 squared. Okay, and you can work that out and see what x would be, and this is x, BC, so you'd get there. Or I could use my trig again. Okay, with this angle right here, this is the adjacent side. Let me write that so we don't get that confused. Okay, the adjacent side, and the opposite is tan. So I could say tan of my angle, 39, equals the opposite over the adjacent. So to find x in either one of those, okay, I would get x is about, and again, this is a side, so 11 divided by tan 39. Oops. Okay, and round to the nearest tenth, I'd get 13.6. There you go, done. That's how you find all the pieces and parts of a right triangle. Okay, go now and do the example, and then I will be back on to show you how that goes.